Hi all, I will present you SMAC, that is Simplified Mandatory Access Control Kernel. The presentation I made at the FOSDEM this year. I was speaking about security model for embedded system using SMAC that is simple but secure. First, some words about the context. I'm José Boyo. I'm working for the company Eurogiciel that is under contract with the company Intel for working on Tizen, the embedded distribution for the Linux distribution for embedded systems. Tizen is using Mac from the beginning on the kernel Linux. Some words about SMAC. SMAC, the main author of SMAC is Keze Chauffeur. SMAC is integrated as a Linux security module in the kernel Linux since the kernel 2.6.25, that is since the 17 April 2008. SMAC was then first introduced at this date, but it is continuously evolving since these first days to be currently a very usable security module that is integrated in the Tizen distribution since the first days, that is in 2012. Okay, it works with the extended file attribute to store the data relating to files, that is context, access context, execution context, transmutation context, map, memory mapping context, etc. It is controlled through the file system interface, whose name is SMACFS, that is working like ASCII interface, ASCII application programming interface, using files. Its main goal is to control the access of the process to other objects like files, IPC, sockets, other processes. That means for other processes the use of the function ptrace or signal. The base of SMAC are the SMAC rules. The SMAC rules have 3 items. There is a subject label, an object label, and the accesses. For example, the rule that you see here grants read, write, and execution access for the processes whose label is system to objects whose label are user. Then now some words of vocabulary about SMAC. What are the labels? Labels are just texts, that is valid ASCII characters without any special meaning. In fact, labels are only used for comparison. This comparison doesn't handle the case, then it is case sensitive, a lower lowercase a isn't like an uppercase A. Subjects. The subjects are the running processes. Any running processes has a SMAC label. The objects are the files. The IPC, that is memory shared, Unix sockets, then the sockets, the processes. Any object has a SMAC label. The label of the running process is called the security context of the process, and some commands are SMAC aware. That means they can tell the user information about the SMAC security. For example, the command ID, that is giving the identification of the current process, will tell, as usual, what is the user ID, what are the group's ID, and also what is the running SMAC context. The process status command PS, also when used with the dash capital Z or dash capital M, will show the context of the running process. The command list files, ls, with the option dash capital Z, prompts the access context of the files. The access context, as I already said, is stored in the extended file attribute. Then that has some impact on the file system that you can use for SMAC. The file system have to handle extended attribute. What are the grantable accesses? As usual, you will find read access, write access, execute access, but you also find append access. That is especially useful for log files. It also handles lock access. That's a real new feature in SMAC, that because previously write access was handled by the write access, but you have to lock some files without having write access to it. So now it's possible with that access. And the last is the transmute access, that allow a process to create file that have by default the access label of the directory where the file is created. Otherwise, the files are by default created with the access label of the process, the context of the process. Setting the SMAC rules. Setting the SMAC context of the files. How to set a context? The answer here is really easy. You can't, except if you have the capability capmac admin and also the capability capmac override, but I will not speak about that. Then root currently have any capability, but other processes can gain capmac admin in very few circumstances, but that's possible. So generally no one can change the access, the SMAC labels of the files. Anyway, to change an access label of the file, you can use the command change smack that allow you to change the access label for a file. You can also change the execution label of a file, the transmit label of a file, and the memory mapping label of a file. On the second line here, you can see how to change the current execution context of the process. You are seeing you can echo the label you want to run on this special file. Note also that echoing the content of that file will show you your current SMAC label, your current security context, that you can also get with the ID command that we already have spoken about. How to set rules? Here the answer is a little more complex. Then you can only, when you're a standard process, you can only reduce your access. If you have access to some resources, then the current rules tell you can do that with this object. Then you can reduce the access you have by using a specific interface, that is the load self2. But if you have the capability capmec admin, you can change all the rules, destroy some and add some using another interface, that is this one. Let's talk about these lines of command. Here you will see the rule, that's a SMAC rule, that is formatted with at first subject label, at second field an object label, and then the access to grant for the subject to the object. Then you echo the rule to the special file that is here mounted here by default, and to this Mac file system. Load self2 is used to restrict accesses for any process. Any process can restrict its accesses. Here the same thing is done, but the file that is accessed here is for the rules of the processes, of the system, of the whole system. Then you can see here, if you cat, that means echo the content of this file, you will see all the rules of the system. The last command use utility whose name is SMACLoad that handle correctly the detection of the mount point and the version of the SMAC kernel that is used. Then that's the most secure way to process the rule in SMAC. This command also can take a file as parameters, what allow you to load into the system a set of rules. Here again, the two last line are only allowed to a process that has the cap-make admin or the cap-make override. Let's speak about Tizen. Tizen is an embedded Linux distribution. Oh, more clear, it's a Linux distribution for embedded systems. Here on the slide you can see some targets that Tizen accesses. Mobile set for telephony, in-vehicle infotainment, television, and small items, small processors context. Here you can see a NUC, next unit computer. The target usage. The target usage for Tizen handle mainly 3 cases, depending on the count of user and the count of interface, user interface. That means here the count of seats. For single user and single seats, we here have the goal of handset for telephony or boxes. For multi-user and single seats, we will find tablet, laptop, etc. And for multi-user and multi-seats, we find a very special case, that is the in-vehicle infotainment, where all the passenger can interact with the infotainment system. IVI, the infotainment, is currently using Wayland that allow multi-seat interface. Then now let's talk about how applications are installed and how the security is handled for applications that are installed on the system. The system here is the trusted system. It have an installer, and here we will have an untrusted application to install. This application will declare that it will use some feature of the system. The user that is installing this application can accept or refuse. If it refused, then the application isn't installed, but if the resource that the application want to use is granted, then the application is installed and the environment of the system is updated. The SMAC rules are updated to handle correctly the security of the application. The idea is that you can't you have to check any access that the application is doing, and if the application violates its manifesto, then the SMAC rules detect it and the application is swept out and terminated. There is another model. This model is composed of an installer and a launcher. This model has some similarities with the other one, but when the application is installed, then the installer assigns the application and tell the security that the application have received grants from the user. And then when the application is launched by a launcher, the security context is updated for that launch. And now, if the application violates its rights, the system is able to detect it and have a coercion action. For Tizen, we had the constraints to allow two kinds of applications. The widget applications that are running on top of a web runtime, that is also the launcher of the application. Then we are in the second model, natively with an install and a launcher. This application then can access the services that it needs and for which they gain a grant. But for Tizen we also have native applications. For these applications, the kernel is the only filter to the access of the service. Then here the SMAC rules have all their weight. Then, because Tizen is using SMAC since 2 years now, we reached the difficulty of the problem. The problem is difficult because it has a power characteristic. Controlling several resources for several access is a big matrix problem that can have a power characteristic as seen here. For example, on Tizen 2.0, that we're using the model with installer only, there was many SMAC rules, not less than 30,000 rules. That's a lot. Each application have its own context label, and the matrix of the access is very sparse, but it's very edge also. For Tizen 3.0 IVI, KZ Schaeffler have promoted the 3 domains model that basically use 3 labels. This one is called floor, that's an underscore character. This one system, and this one user. The rules are restricted to a very small account. We are currently running IVI with an average of 30 rules, but it may require a launcher to achieve the full control, and we spoke about that. How is working the 3 domain model. Then the floor domain is here for the base system. That means all what is common Linux commands, Unix commands, Unix files are by default set to floor. Floor is a special label that means that any process has a read and execute access to this domain. That's the default. Then the services are run under the system domain, and you can find here some variation of the system domain: system run, system shared, system logs. This one for the logs, this one for the IPC to the domain, shared that is for memory. And the application then are using, the user applications are using the user domain and have accesses to some kind of system, some services provided by the system domain, and all the accesses, the services provided by the bus system. You can dig deeper into SMAC using these links. This one and this one are the base for understanding SMAC. This one is the repo where the SMAC tools are provided. That means we didn't enter in deep with these tools, but we have seen two of them that are change SMAC and SMAC load. There are many other aspects related to IPC and sockets. That means use of CISPSO, the IP security over Internet. And here you will find more data about SMAC into Tizen. And here the description of the free domain model. To finish, what you have to keep in mind that Tizen have SMAC. SMAC is really easy and simple to learn, and you can contribute to improve SMAC tools and models. Thank you.